So this is a more general overview for early stage investigators. So self-assessment. So the most important piece of that is your publication record. So people often sort of look at their publication record and they're concerned that they're not ready for, this independent award. So if you're concerned, that's reasonable and maybe just good judgment. But you should seek guidance from an experienced mentor to say, I've seen a lot of RO3s and, this publication record isn't going to be strong enough for an RO3. That's not a problem. There's still other ways. Like I said, there's, some place for everybody to jump in, the NIH funding stream. So if you're not appropriate for one mechanism, you may be appropriate for another mechanism. You have to consider what specialized training you've had. So that goes into what you worked on last night with the specific aims. Where does your training point you? Not what is it you want to do, right? This is what's your background? What is your preparation? What is it that a reviewer can look at objectively and say, oh yes, this person's a good candidate for this project, for this mechanism, this institute? What do you have available to you? What resources are available? What people are available? What mentoring team is available? I talked about this yesterday too, assembling your team. Don't be shy about assembling the strongest people that you can find. And that's not just people at your institution, but people who are anywhere in the world. When you have people that are not at your site, the bar gets a little higher in terms of demonstrating your sort of logistical connection. But you can do that. You can say we have Skype meetings every Tuesday at 2 a.m. To accommodate this person's schedule in Beijing, but we really need their help. And so, the demonstrating the logistics can be a really important part of showing that this team is real. So get those experts on your team, show that you've had communication, and show how the distribution of authority is arranged. You really are the project director, the PI for an RO3. Or the sponsor really does have control of this team, that everybody's role is kind of defined and responsibilities are clear, and it makes it much more compelling. So I do want to spend just a minute talking about how you negotiate things at your institutions, because those of you that aren't at research-intensive institutions, so you're in a tight spot where they have the expectation that you'll do that you'll be productive in terms of grant generation. Why wouldn't they want to put that pressure on you? They love the cash. They don't have very many cash streams, and your salary release is a lot more than they're going to have to pay to buy out. Have to pay adjuncts, and the indirects are great. So everything is in the institution's interest to sort of provide pressure for you to seek external funding. That's fine. That's the way it should be. You want to seek external funding. You wouldn't be here otherwise. The pressure that has to go back to them is to say, yes, I understand you want me to do that, but I need time to do that. So the difficult spot that sometimes you run into is that if the grant culture isn't part of your institution, there can be the expectation that you keep teaching, or that you somehow provide oversight of what was your instructional responsibility, or you keep advising 50 students sometimes, or so there has to be some kind of accommodation, and the review committee is going to take it as their responsibility to make sure that your time is protected. NIH it's not a contract. You have to be very careful to distinguish between a contract and a grant. But in this sense, you can sort of look at it as a contract that taxpayers are paying for your time. And the review committee is going to make sure that that time is built in and it's protected. And it's your job in preparing for the grant to make sure that the institutional letter of support reflects an appropriate amount of release time. And for a new investigator, that should be paid by the grant. So you should actually release, salary dollars, pay for salary in your grant budget on the order of, 20 to 50%. I mean, it should be a substantial investment in your time by the funding agency. Your time is the best thing they can buy. They don't want to buy you a new lab. They don't want to pay for, 400 grad students. They want to buy your time. That's the most valuable thing on the grant, so you should make a serious commitment to it, and your institution has to back you up. And if they don't back you up, if they push back too hard on that, then There are a lot of institutions out there that would be very happy to add you to their team. So I already talked about clinical facilities and demonstrating research relationships with them, documented access. So finally, after all of that stuff, then you finally get to talk about your idea. I mean, what's amazing is there's all this sort of structure you have to build up. I mean, logistical structure you have to build up before you can even talk about science. And so that's part of this program is you have to learn all of these logistics, all of the, the culture and the acronyms and the people that you need and all of this sort of non-scientific stuff that you need to support your science. But when you finally get down and get to think about your idea, I think I've mentioned this yesterday, is it should be feasible and it should have demonstrated feasibility. It should have, this is a weird balancing act, but it should have a high likelihood of success. So it doesn't mean this experiment, some people interpret that to mean that you should know what the outcome of the experiment is before you do it. Or I've even heard people say that your first aim should already be in the can before you submit the application. That's not true. People can smell that, and that will not go well. Nobody wants to pay for work that's already been done, but people feel like that's a way to assure that you know what the outcome is going to be. That's not the case. The idea is that you should know your science well enough that you can make you have a strong guess, I suppose, of what the outcome is going to be. And even better, if there are alternate outcomes, you can even say how one alternative or the other is going to steer science one direction or the other. So that's a real bonus, if you have strong alternate theories, competing theories. So, and then you already did this because you had specific aims of having clear experimental objectives.